Welcome to another episode of Easy Science. I'm Ellen Stofan, the John and Adrian Mars Director of the Smithsonian's National Air and Space Museum, or Dr. E.
And I'm Thomas Zurbuchen, the Associate Administrator for Science at NASA, also referred to as Dr. Z.
We're here today to talk about a subject that's pretty near and dear to my heart, and that's the Hubble Space Telescope. You can see behind us the structural dynamic test vehicle of Hubble, and after the side here at the National Air and Space Museum, we have some of the instruments that were actually brought back from Hubble. The ones that weren't working so well, they had to put new instruments up on board. So if you haven't been here before, come and see this amazing history of Hubble.
To me, this is one of the real highlights in the museum, and kind of every time I'm standing here, I'm in awe. So first of all, this mission is what I would consider the most important discovery mission we've ever done. If you look at that mission last year alone, there are close to 1,000 new publications written. It's not just a science mission, it's a science mission enabled by human explorations by astronauts.
The fact that the astronauts were able to go up in the shuttle and replace the instruments, constantly putting better, more advanced instrumentation on board, has really allowed Hubble, over its 29 years, to completely change our view of the universe.
So there's a story that was out there about a planet called K218b. And here's a question we got with the hashtag EasyScience, and it said, Hubble just found water vapor on an exoplanet in a habitable zone. What does that mean for other planets?
So recently, some scientists actually discovered water vapor in the atmosphere of this planet. We now have over 4,000 planets around other stars that have been detected. A lot of them are very large, so we're not really thinking about those as sort of Earth 2.0, a place where we could go to look for life. But the intriguing thing is, we're pretty sure water is critical to life. Life here on Earth evolved in the oceans, so when we go out and look at planets around other stars, we're looking for that blue planet, that ocean planet like the Earth. So the fact that we found water vapor was exciting, but unfortunately not sufficient, because habitability is a complicated thing.
Yeah, so we found water here, water vapor, but there's many questions we have about, for example, do these planets have magnetic protection layers like our Earth? Is the surface actually solid, or would it just sink in? Like if something is a gaseous type of planet? There's many, many questions. So we're just at the beginning of that journey.
That's right, and when you look at our own solar system, obviously the Earth is habitable. It's been habitable for hundreds of millions of years, and yet if you look at Venus or Mars, Mars was habitable for a very small portion of its history, and a lot of us feel strongly that there could be evidence of past life on Mars. Venus was maybe habitable for a very short time in its history, and early in Earth's history, this planet was not habitable, and as our solar system evolves, Earth will become no longer habitable. So you have to think of habitability as not just a condition, but actually a phase that a planet could potentially go through.
What we have done with the exoplanets is we've, using Kepler, looked at one part of the sky and just stared at it. And from that, we managed to do a tally of exoplanets. So we know that for every star, at least, there's one exoplanet out there. Most of those exoplanets live in systems, just like we do. There's other planets in our solar system. What we're now doing with tests is we're looking at the entire sky to really find the closest such things to investigate. And like you said, there's very little we know about this. It's very critical to be able to follow up with telescopes like this one, the Hubble Space Telescope, but also James Webb, that's coming out in just a couple of years up there.
We're incredibly excited about the James Webb Space Telescope, because if you think of TESS, Kepler, Hubble, finding these exoplanets and getting a little bit of information, James Webb is really going to be able to take us to the next level.
What's really amazing about Webb is when Webb was conceived early on, exoplanets were a kind of a side story. right now, it's one of the key stories because we discovered this abundance of exoplanets and we have an abundance of questions, many, many questions that we didn't even know how to ask before.
So what the Webb telescope can do is it can look at much higher resolution of the atmospheres of some of these planets around other stars, not just looking for water vapor, but also gases like carbon dioxide, methane, and it's these combinations of gases that we're looking for. The presence of water vapor isn't sufficient for life, but if you see a mixture of gases, and especially if those gases seem to be out of equilibrium, or there's something causing an imbalance in the gases chemically in the atmosphere, that starts to make us think, not only could that planet be habitable, but is it actually inhabited? When I started out as a planetary scientist, there were 9 planets, and then because of the declassification of Pluto, we went down to 8. But for kids who are students now, by the time they're ready to become planetary scientists, which of course they're all going to do, there are going to be thousands of planets for them to study. And we got another question on Easy Science, and it's asking about TESS. What is the Transiting Exoplanet Survey Satellite? How does that actually work?
What the TESS mission is doing, it's looking in a large part of the sky and it's staring at it. And as it's staring, it's looking at the stability of light. So every once in a while, one of those exoplanets is going right in front of the star that it's around. And when it does so, it ever so faintly reduces the light of that star, creating a transient feature. And so that's what we're observing for all those stars in that part of the sky that TESS is looking at.
And we can then use how the light has dimmed to say what's the size of that planet, what kind of orbit it's in, which really helps us then start to nail down which of these planets are more like Earth, which ones are more like Jupiter. We're just about out of time, I'm sorry to say. Thank you for joining us for another episode of Easy Science.
And please keep sending those questions with #EasyScience so we can answer them at the next episode of Easy Science.